Well, so we are starting off with motion in 1D, one dimension. Okay? Now, before we start off with motion in one dimension, I'll just go back to class 9 once and go for a flashback and see what we have done. Okay? First, how do you say a body is at rest or motion?
Changes its position with respect to time.
And space with respect to position, its surroundings, changes its position with respect to its surroundings as well as time. Then we say the body is in motion, and rest obviously when it doesn't change, right? So the next thing is there anything called absolute rest and absolute motion? Why not?
Because everything is related.
To what?
Observation.
Right. So if you see a body to be at rest, it is not necessarily that for every observer on the earth the body will be at rest. Okay. Very good example is when you are sitting with your friend in a school bus and you see another friend standing on the road. So the friend who is standing on the road, you will say that both you and your friend in the bus are moving in motion. But you will say that your friend who is sitting beside you is at rest. Right? So none of you are wrong. Both of them are correct. Why? Because there is nothing called absolute rest or absolute motion. So any body which is appearing to be at rest with respect to you, maybe with respect to motion, somebody else. For example, all of you over here are at rest, but for a person who is in the spaceship, you will say the earth is rotating. So with the earth, you all are rotating. So none of them are at rest. Right? So this concept of rest or motion is purely dependent on
Individuals.
On the individuals, observer and individuals. Fine, fair enough. So we are done with the state of rest or motion. Now comes the types of motion. Okay. So before we go for discussion of types of motion, we need to mention that we are doing motion in 1D. Motion in 1D means over here the motion will take place along a straight line. Motion in 1D means motion along a straight line. The direction will not. Only what direction can change? Just opposite. Means if you take a stone and throw in the upward direction, will it keep on going upward forever? What happens?
Gravity.
It goes up to a certain point, comes momentarily at rest, and then returns back. But along the same path, that is motion in 1D. Okay. If it changes the direction, that will be motion in 2D or 3D. We'll be doing it later. Alright? Now, before we start off with this motion, I need to tell you something about the physics. Physics means, till now, like the chapters we did earlier, were more about mathematics, dimension analysis, error analysis, were more about mathematics. We'll learn more mathematics in this chapter also. But the first part of the physics of class 11 is called mechanics. What do we call it?
Mechanics.
Right. So, mechanics, it is classified into two parts: kinematics and dynamics. Okay. What is kinematics? Kinematics deals with the know-how of motion. Know-how of motion means how much speed, how much displacement, how much acceleration, how much time did it take to do so. This is know-how of motion. Okay. And dynamics deals with know why of motion. Means why is this motion taking place? क्यों हो रहा है? ठीक है? So क्यों हो रहा है कौन बताता है? न्यूटन बताता है. So Newton's laws जहाँ से हम लोग शुरू करेंगे, that is dynamics of motion. But prior to that, when you are making only calculations with the motion variables. So what are the motion variables? Displacement, velocity, acceleration, time. All these things are dynamics. Is that clear? So this is know-how and this is know-why. Know-how and know-why. Alright? Now comes an important part. So we are starting off with the kinematics, and in kinematics we are doing one dimension kinematics, with motion in one dimension. Alright? So first concept, types of motion. What are the different types of motion? We have if we are dealing only motion in 1D, okay? So if we broadly classify motion, then there will be motion in 1D, motion in 2D, circular motion. So there are different types of motion, vibratory, oscillatory motions, all those will come. But when we are talking about only motion in 1D, in that we have classified the motion into two types. One is uniform, another is non-uniform. So what do you mean by uniform motion and what do you mean by non-uniform motion? Uniform motion or non-uniform motion?
Covers equal distance, equal intervals of time.
Right. So uniform motion under कौन बोले स्वरूप ना? When a body covers equal displacements in equal intervals of time.
Velocity is constant.
Right. It's very important. The velocity is constant. So if the velocity remains constant, you say the body is going for a uniform motion. Okay. Now, in uniform motion, what are the situations that arise for uniform motion? The only relation is velocity equal to displacement by time. S by V equal to S by V. Displacement and V velocity. Okay, and the velocity is constant. Velocity is equal to constant. That is what you call uniform motion. So the funny thing about uniform motion is you ask for the velocity at any instant, it remains the same. It does not change it. No let it change. Yes. And of course, if you want to find out the displacement, you just write velocity into that its distance. So uniform motion का सिर्फ एक इक्वेशन s equal to v. Done? लगना हो रहा है done? Next coming non-uniform motion. Non-uniform motion like what is non-uniform motion? Non-uniform motion like of course it does not travel equal distances in equal intervals of time. Equal distances, equal intervals of time and travel constant. Means the velocity is not constant. Velocity is not constant. Now, how is it changing? That is different. But primarily, velocity is what? Not constant. Velocity change. Okay? Velocity will change. So, non-uniform motion implies velocity must change. Velocity must change. Okay? So, under non-uniform motion, the most used type of motion is uniformly accelerated motion. Uniformly accelerated what is this? This comes under non-uniform motion. Okay? Non-uniform motion at a type of uniformly accelerated motion, correct or non-uniformly accelerated motion. Non-uniform acceleration. But we are not that much bothered about this. Okay? We are more bothered about uniformly accelerated motion. So our today's point of discussion is uniformly accelerated motion. So we will do all the possible situations under uniformly accelerated motion. First, tell me what do you understand by the term acceleration?
Changing velocity by time.
Acceleration is defined as rate of change of velocity. Means not only change in velocity. Change in velocity divided by time. The velocity is changing, but how fast or how slow? That is acceleration. Okay. So, acceleration is the rate of change of velocity. So, for uniform acceleration, you can write the acceleration as v minus u by t. V is what? V is what?
Final velocity.
Final velocity. U is initial velocity and T is time interval. Time interval. Okay. So this is something we did in class 9 itself, right? 9 was not a answer. V minus U by T, acceleration equal to V minus U by T, right? We did it. Right? Now, I just need to tell you something before we proceed any further. So before we proceed any further, I need to tell you something, some important things. Okay. When we are dealing with changing velocity, see velocity must change, right? So that means velocity is not same everywhere. So say you are inside a car and the car is moving. Does the velocity remain constant all through? No. When the signal comes, you have to apply brakes, stop. And when the signal turns green, then you start moving. But you cannot move freely. Why? Because there is a lot of traffic. ट्रैफिक में सब लोग फंसे हुए हैं. तो पहले वाला गाड़ी जाएगा, उसके बाद एक ऑटो घुस जाएगा सामने से, हमारा जगह बंद. ब्रेक लगाना पड़ेगा तुमको 10 बार, right? So your velocity will not be same all the time. It will keep on changing, right? When the velocity keeps on changing, there is a very important term that arises, which we call the instantaneous velocity. What is meant by this? We denote it simply with v or v instant. Simply with v or v instant.
Velocity in that moment.
Velocity at that moment. But what do you mean by velocity at that moment? Velocity is change in position by change in time. That is displacement by time, right? So at any instant you are saying displacement. How is that possible? Is that possible? At any instant, the car is at any particular place. Until and unless it changes the place, how do you calculate velocity? Slow down. At a body যদি place change না করে তাহলে আমরা velocity কি বার করতে পারবো? Because there is no displacement in it. Alright, so I'll tell you something. একটু মন দিয়ে শুনুন. Instantaneous velocity পাওয়ার আগে আমরা একটা average velocity. Now this is a very simple formula. What is average velocity? It is delta s by delta. What is delta s and delta t mean? Delta change in position. Change is called delta. It's finite change. This is very important. The term delta implies finite change. Finite change. So let's so delta is what? Finite change. What do you mean by finite change? इसका मतलब क्या है? Finite change मतलब the change which you can calculate. The change that you can calculate. How do you find it out? Simple. Final minus initial. Final minus initial. Always. Whenever they say delta, it always means final minus initial. Okay? So when I write average velocity, it means finite change in position by finite change in time. So change in time means time interval. What is it? Say time interval. So delta t is basically time interval. Alright? Now, when we are discussing about instantaneous velocity, instantaneous velocity. That means what? We are talking about a time instant. So do we have an interval anymore? We don't have an interval anymore. So if we don't have an interval and we are talking about instant, then for any instant the interval is how much? 0. Right? So whenever we say time instant means delta t is, so if we put 0 at the denominator, will we get a calculatable value? मिलेगा repeatable value? No, it will go for undefined value, right? That is why for calculating instantaneous velocity, we cannot use algebra. Algebra use नहीं कर सकते, and that is why Newton came up with an idea. What? Using calculus. Newton actually found calculus for the first time. তার আগে calculus বলে কিছু ছিল না। Newton was not only a physicist, he was a mathematician. Actually, one of the biggest mathematicians. He discovered calculus. हाँ? क्या कहते हैं? Leibniz, हाँ. But the thing is, Newton's mathematical skills were way stronger, hugely stronger, and that's why he devised a new part of mathematics, obviously with Leibniz, as is told. So, with Leibniz and Newton devised a new tool or a new part of mathematics which can be used where algebra cannot be used. Okay? So, what did we do? He told that don't take del t equal to 0. Take delta t approaching 0. Take it to be very close to 0 but not exactly touching 0. Then what happens? It will not become undefined. It will remain defined, but you will get your correct value. So what is it? Right? You know, limit of delta t approaching 0. Delta s by delta means the time was given as an interval. What did he do? He made it as an instant. Made it very small. Okay? But not exactly equal to 0. Okay? Tending to 0 means close to 0. Now I'll ask me, sir, how close to 0? Nobody knows. Nobody knows how much close to 0. Very close to 0. Like point, then 1,000 zeros, and then 1. So that is very close to 0, but is it equal to 0? No. So it is defined. It is defined, but doing the calculation will be a real difficult task. Okay. Now, remember, this is just a representation. There is no mathematics in it. You don't need to do any mathematics over here because I won't do calculus over here. This assignment doesn't have any calculus. This is just an introduction to make you understand why do we need calculus. हम लोग calculus क्यों चाहिए? Because the place where algebra fails, you need to introduce calculus. Clear? এই যে আমরা বলছি ইনস্ট্যান্টেনিয়াস, এর মানেটা কি? এর মানেটা হচ্ছে যে কোনো একটা মুহূর্তে, তো যে কোনো একটা ইনস্ট্যান্ট মানে কি? সেখানে টাইমটাকে চেঞ্জ করছে। when you take a picture, a still picture, পিকচারটা যখন তুমি নাও, তখন কি সেটা দেখে বোঝা যায় তার মধ্যে কোন কোন জিনিসগুলো মুভ করছে, কোন কোন জিনিসগুলো রেস্টে আছে? স্টিল জিনিস, তাই না? তো দ্যাট ইজ অ্যান ইনস্ট্যান্ট। ওটা হচ্ছে ইনস্ট্যান্ট। তাহলে সেই ইনস্ট্যান্টে ডেল্টা টি এর ভ্যালুটা কত হয়ে যাচ্ছে? তো সেটা কি আমরা এখানে ইউজ করতে পারবো? না, ডিফাইন কোনো ভ্যালু পাওয়া যাবে না। সেই জন্য এই লিমিটেড কনসেপ্টটা বোঝা গেছে? Now how do we use limit and how do we work with it? We'll learn later. পরে শিখব। Less than zero. Slightly greater than zero, right? Slightly greater than zero. Less than zero হলে তো হবে না, undefined. Right? Now you know by default we are lazy. That is our birthright. Laziness is our birthright. So obviously scientists are actually more lazy. So this is a very difficult thing to write every time limit of delta t approaching 0 delta x by delta t delta t approaching 0 delta x by delta t. So they wrote it in a small manner. What did they write? Yes. Instead of writing this whole big thing, they just wrote ds. Now what is d? Remember delta was finite change. So what is d? D is infinitesimally small change. Now, what does that mean? Like you say, extremely big is infinite. Similarly, extremely small is infinitesimally small. Okay. So when we talk about infinitesimally small change in value, we write it as d. So when I write ds, what does that mean? It means infinitesimally small change in s. And what is dt? Infinitesimally small change in t. That's something you cannot calculate, but you can use for mathematics. हम लोग कैलकुलेट नहीं कर सकते हैं, बट हम लोग यूज कर सकते हैं, ठीक है? उसको यूज करके कैलकुलेट कर सकते हैं. How do we use and how do we calculate? I'll tell you later. But remember, average velocity will be always denoted as v average, VAVG. If they are saying average velocity, you need to represent it as VAVG. But instantaneous velocity, you don't represent it with VIST. You just write V. Remember, after this, whenever you see V, it does not mean the average velocity. It will always mean the instantaneous velocity. Means this is a variable. It will keep on changing. Is that clear? Instantaneous velocity জন্য আলাদা করে v instantaneous লিখতে আমাদের লাগে না। শুধু v লেখা মানেই হচ্ছে সেটা হচ্ছে instantaneous velocity. v
INS equal to
না সেটা লিখবো না, সেটাই বলছি। v ins লিখবো না, just normally লিখবো। সেটা মানে instantaneous velocity, right. Now onwards, whenever it is being written v is equal to this, you will understand it is instantaneous velocity, not average velocity. If it is average velocity, it will be mentioned separately. Clear? Clear to all of you? Again, you have seen acceleration is v minus u by t. This is actually average acceleration. Average acceleration. Okay. Now, if you want to represent the instantaneous acceleration, that is represented as limit of delta t approaching 0, delta v by delta. This one looking short DSD. And dvdt. Sorry, close up. Right. এটাকে dds of p মানে ddt of s বলে আর এটাকে ddt of v বলে. Remember, it is not ds by dt. Remember বলবে না, when you are speaking out, don't say ds by dt, say ds dt. The by is silent, you don't say the by, ঠিক আছে? আর এখানে instantaneous acceleration বলার সময় dvdt বলা, ঠিক আছে? আরেকটা better way of representation is like this, ddt of s ddt of s or ddt of v. This is for the representation. These are just the representations here. How do I work with it? We'll come to it later. This is just the representation. Now, when we are dealing with uniformly accelerated motion, you don't need to write a average. A average, you write it as a. Why? Because it is uniformly accelerated motion. The value of acceleration does not change. So, instantaneous value of acceleration and average value remains the same. Doesn't have any difference. Correct? তার কারণটা হচ্ছে এই যে মেনশন করা আছে ইউনিফর্মলি অ্যাক্সিলারেটেড মোশন, মানে ইউনিফর্ম কথাটার মানে হচ্ছে কনস্ট্যান্ট। যেমন ইউনিফর্ম মোশন আপনি আসার আগে হয়ে গেছে, না ইউনিফর্ম মোশন কথাটার মানে হচ্ছে কনস্ট্যান্ট মোশন, মানে ভেলোসিটিটা কনস্ট্যান্ট। আর যেই নন ইউনিফর্ম মোশন হয়ে যাবে, ইট ইজ ভেলোসিটি মাস্ট চেঞ্জ। আর সেই নন ইউনিফর্ম মোশনের দুটো পার্ট, ইউনিফর্মলি অ্যাক্সিলারেটেড মোশন আর নন ইউনিফর্মলি অ্যাক্সিলারেটেড মোশন। So non-uniform acceleration আমরা এখন অতটা bothered নই, we are more bothered about uniformly accelerated motion. Clear? বোঝা গেছে? So let's start off with a proper discussion of uniformly accelerated motion. এটা লেখা দরকার ছিল, কোথায় লেখা হয়নি? এখন অবধি আমি কিছু মুছছি না।